Ancient Roman engineering stands as a testament to the ingenuity and advanced technological capabilities of the Roman civilization. One of the most remarkable engineering achievements of the Romans was their extensive network of aqueducts. These structures, built with meticulous precision, transported water from distant sources to urban centers, providing essential water supply for public baths, fountains, and private households. In fact, it is estimated that at the peak of the Roman Empire, over 11 aqueducts supplied Rome with approximately 1 billion gallons of water daily. This impressive feat of engineering not only improved public health and sanitation, but also facilitated the growth and prosperity of Roman cities. Another key aspect of Roman engineering was their road construction. The Romans built an extensive network of roads spanning over 250,000 miles, connecting far-flung regions of the empire. These roads were crucial for the movement of troops, goods, and communication, enabling the efficient administration and control of the vast Roman territories. Roman military engineering also played a pivotal role in the expansion and maintenance of the empire. The construction of fortified walls, bridges, and siege engines allowed the Roman army to conquer new territories and defend existing borders effectively. The Romans were also pioneers in urban planning and architecture, designing cities with organized layouts, public spaces, and impressive structures such as amphitheaters and temples. The legacy of Roman engineering continues to influence modern infrastructure and construction practices, showcasing the enduring impact of their technological advancements. The Roman aqueducts are among the most iconic and impressive engineering feats of the ancient world. These monumental structures were designed to transport water from distant sources to urban centers, ensuring a stable water supply for various purposes. One of the most famous aqueducts is the Aqua Appia, constructed in 312 BC, which was the first ever Roman aqueduct. It ran for 16.4 kilometers and supplied water to the city of Rome. The Aqua Claudia, built between 38 and 52 AD, was one of the longest aqueducts, stretching over 69 kilometers. It had a capacity of delivering 190,000 cubic meters of water per day to Rome, showcasing the scale of Roman engineering prowess. The Romans utilized a combination of gravity and precise engineering techniques to maintain a steady flow of water through the aqueducts. The arches and tunnels of the aqueducts were constructed with such precision that some of them are still standing today, a testament to the durability of Roman engineering. The Pont du Gard aqueduct in France is a prime example of Roman aqueduct architecture, with its 3 tiers of arches spanning the Garden River. This aqueduct, built in the 1st century AD, stands as a UNESCO World Heritage Site and attracts visitors from around the world. The Romans also implemented innovative water management systems to ensure the efficient distribution of water to different parts of the city. They constructed underground reservoirs and distribution networks to regulate the flow of water and prevent wastage. The Cloaca Maxima, an ancient sewer system in Rome, was another remarkable engineering achievement that facilitated the removal of wastewater from the city. It was built in the 6th century BC and is considered one of the earliest examples of urban sanitation engineering. The Romans understood the importance of clean water and sanitation for public health, leading them to invest heavily in water infrastructure. The impact of Roman aqueducts extended beyond providing water for daily use. They also supported the development of industries such as mining, agriculture, and manufacturing by supplying water for irrigation, mining operations, and industrial processes. The aqueducts played a crucial role in sustaining the growing population of Roman cities and supporting the expansion of the empire. The Roman aqueducts were not only engineering marvels but also symbols of Roman power and civilization. Their grandeur and sophistication reflected the wealth and technological advancement of the Roman Empire, leaving a lasting legacy in the annals of history. The Romans were renowned for their extensive network of roads, which played a crucial role in the development and expansion of the empire. One of the most impressive feats of Roman road construction was the Appian Way, also known as Via Appia, which connected Rome to the southern regions of Italy. Built in 312 BC, It stretched over 560 kilometers and was lined with large stone slabs, making it durable and long-lasting. Another remarkable road, the Via Augusta, extended over 1,500 kilometers from Rome to Cadiz in Spain, showcasing the vast reach of Roman infrastructure. The Romans constructed roads with a standardized width of approximately 4.8 meters, allowing for the smooth passage of wheeled vehicles and facilitating trade and communication. It is estimated that the Romans built over 250,000 miles of roads throughout their empire, a staggering feat considering the technology available at that time. These roads were not only essential for military movements, but also facilitated the transportation of goods, people, and information across the vast territories of the empire. The Roman roads were equipped with milestones, marking the distance to Rome and serving as a means of communication and control. The milestones also provided valuable information for travelers, indicating the distance to the nearest town or city. The efficiency of Roman road construction can be seen in the durability of many ancient roads that are still in use today. For example, the Via Flaminia, built in 220 BC, remains a major thoroughfare in Italy, connecting Rome to the Adriatic coast. The Roman roads revolutionized travel and trade in the ancient world, contributing to the economic prosperity and cultural exchange within the empire. The legacy of Roman road engineering can be observed in modern road construction techniques, highlighting the enduring impact of Roman infrastructure development. Military engineering and fortifications were integral to the success of the Roman army in conquering and maintaining control over vast territories. The Romans were adept at constructing various types of fortifications, including walls, forts, and siege engines, to protect their borders and strategic positions. One of the most famous examples of Roman military engineering is the construction of Hadrian's Wall in northern England. Built by Emperor Hadrian in 120 AD, the wall stretched over 73 miles and served as a defensive barrier against invading tribes from the north. The wall was up to 20 feet high and included defensive fortifications such as watchtowers and gates. Another impressive fortification built by the Romans was the Antonine Wall in Scotland, constructed by Emperor Antoninus Pius in 140 AD. This wall spanned 37 miles and was equipped with defensive ditches and forts along its length. The Romans also utilized advanced siege engines, such as ballistae and catapults, to besiege enemy fortifications and cities. These powerful weapons were capable of launching projectiles with great force and accuracy, enabling the Roman army to overcome fortified defenses. In addition to fortifications, the Romans were skilled in constructing military camps, known as castra, to house and organize their troops during campaigns. These camps were strategically designed with defensive walls, gates, and internal layouts to optimize military operations and logistics. The Roman army also employed innovative engineering techniques in the construction of bridges and roads to facilitate the movement of troops and supplies. The construction of the Trajan's Bridge over the Danube River in 105 AD is a remarkable example of Roman bridge engineering. The bridge, which spanned over 3,000 feet, was constructed using wooden piers and stone arches, showcasing the Romans' mastery of bridge construction. The Roman military engineering achievements were not only instrumental in securing the borders of the empire, but also in projecting Roman power and influence across distant lands. The legacy of Roman military engineering can be seen in the strategic fortifications and defensive structures that still stand today, serving as a testament to the engineering prowess of the Roman army. Urban planning and architecture were integral components of Roman civilization, reflecting the Romans' commitment to creating functional and aesthetically pleasing cities. Roman cities were meticulously planned with straight, grid-like streets intersecting at right angles, forming a well-organized layout. The city of Pompeii, famously preserved by the eruption of Mount Vesuvius in 79 AD, provides a glimpse into Roman urban planning. Pompeii's streets were lined with shops, houses, and public buildings, showcasing the vibrant urban life of the time. The Romans also constructed impressive public spaces, such as forums and amphitheaters, which served as centers of civic life and entertainment. The Colosseum in Rome, built in 70 AD, could accommodate up to 50,000 spectators and hosted gladiatorial contests, animal hunts, and other spectacles. Roman architecture was characterized by the extensive use of concrete, allowing for the construction of large, durable structures such as aqueducts, bridges, and amphitheaters. The Pantheon in Rome, built in 127 AD, is a prime example of Roman architectural innovation. Its massive dome, with a diameter of 143 feet, remains the largest unreinforced concrete dome in the world. Roman architects also incorporated elements of Greek and Etruscan architecture into their designs, creating a unique blend of styles. The Romans were prolific builders, constructing numerous temples, basilicas, and public baths throughout the empire. The city of Rome itself was a showcase of Roman architectural grandeur, with monumental structures such as the Circus Maximus, the Baths of Caracalla, and the Arch of Constantine. The legacy of Roman urban planning and architecture can be seen in the layout of modern cities, with grid-like street patterns and public spaces inspired by Roman design principles. The advanced engineering achievements of the Romans played a significant role in their territorial expansion and management of conquered lands. The construction of roads, bridges, and aqueducts facilitated the movement of troops and supplies, enabling the Roman army to conquer new territories with greater efficiency. The Roman road network, which spanned over 250,000 miles, allowed for rapid mobilization of troops and communication between distant regions of the empire. This strategic infrastructure not only connected Roman cities, but also linked military outposts and frontier regions, strengthening Roman control over conquered territories. The Roman aqueducts, with their ability to supply water to urban centers, supported the growth and development of newly acquired lands. For example, the aqueducts in North Africa provided essential water supply for Roman colonies and agricultural settlements, enabling the Romans to establish thriving communities in arid regions. The Romans also utilized their engineering expertise to construct fortifications and defensive walls along the borders of the empire. Hadrian's Wall in Britain, stretching over 73 miles, served as a formidable barrier against invading tribes from the north, showcasing the Romans' commitment to securing their territorial holdings. The Antonine Wall in Scotland, built by Emperor Antoninus Pius, further exemplified Roman military engineering prowess in fortification construction. These defensive structures not only protected Roman territories, but also projected Roman power and authority to neighboring regions. The impact of Roman engineering on territorial expansion is evident in the lasting legacy of Roman infrastructure across Europe, North Africa, and the Middle East. The strategic placement of roads, aqueducts, and fortifications shaped the territorial boundaries of the Roman Empire and influenced the management of conquered lands for centuries to come. After conquering new territories, the Romans implemented a systematic approach to manage and govern their vast empire. One key aspect of managing conquered lands was the establishment of Roman colonies, which served as centers of Roman culture, administration, and military control. These colonies were strategically located in newly acquired territories to ensure Roman influence and control over the local population. The Romans also implemented a policy of granting Roman citizenship to inhabitants of conquered lands, thereby integrating them into the Roman social and political system. This practice helped to foster loyalty among the local population and facilitate the assimilation of diverse cultures within the empire. The Roman government appointed governors, known as proconsuls or propraetors, to oversee the administration of provinces and ensure compliance with Roman laws and policies. These governors were responsible for collecting taxes, maintaining order, and implementing Roman infrastructure projects in their respective territories. The Roman army played a crucial role in maintaining control over conquered lands, with legions stationed in strategic locations to deter rebellions and external threats. The Romans also employed a system of client kingdoms, where local rulers were allowed to retain their authority in exchange for loyalty and tribute to Rome. This practice enabled the Romans to extend their influence without the need for direct military occupation. The Roman Empire was divided into administrative regions called provinces, each governed by a proconsul or propraetor appointed by the Roman Senate. provinces were further subdivided into smaller administrative units, known as civitates, which were responsible for local governance and tax collection. The Roman system of governance and administration laid the foundation for the efficient management of conquered territories and the long-term stability of the empire. The legacy of Roman engineering continues to captivate and inspire generations with its enduring impact on architecture, infrastructure, and technology. One of the most remarkable legacies of Roman engineering is the enduring durability of their structures. The Pantheon in Rome, with its iconic dome, stands as a testament to the Romans' mastery of concrete construction. The dome of the Pantheon, with a diameter of 143 feet, remains the largest unreinforced concrete dome in the world, showcasing the innovative engineering techniques employed by the Romans. Another fascinating aspect of Roman engineering is the scale of their infrastructure projects. The Roman road network, spanning over 250,000 miles, facilitated trade, communication, and military movements across the vast expanse of the empire. The aqueducts, such as the Aqua Claudia, delivered an impressive 190,000 cubic meters of water per day to the city of Rome, highlighting the Romans' expertise in hydraulic engineering. Roman engineering also left a lasting impact on urban planning and architecture. The grid-like street patterns, public spaces, and monumental structures of Roman cities continue to influence modern city planning and architectural design. The legacy of Roman engineering can be seen in the enduring structures that have withstood the test of time. The Pont du Gard aqueduct in France, with its 3 tiers of arches spanning the Garden River, stands as a UNESCO World Heritage Site, attracting visitors from around the world. The Roman engineering legacy serves as a reminder of the ingenuity, innovation, and vision of the ancient Romans, whose technological achievements continue to inspire awe and admiration to this day. One of the most impressive engineering projects of ancient Rome is the Pont du Gard aqueduct in France. This aqueduct, built in the 1st century AD, spans over 3 tiers of arches, reaching a height of 8 meters. The Pont du Gard is a marvel of Roman engineering, with each tier of arches decreasing in size to support the weight of the structure. The aqueduct transported water from the Ur spring to the Roman city of Nemausus, present-day Nîmes, over a distance of 50 kilometers. The Pont du Gard is a UNESCO World Heritage Site and attracts over 1 million visitors annually, showcasing the enduring legacy of Roman engineering. Another remarkable engineering project is the Colosseum in Rome, also known as the Flavian Amphitheater. Built in 70 AD, the Colosseum could accommodate up to 80,000 spectators and hosted gladiatorial contests, animal hunts, and other spectacles. The amphitheater featured a complex system of underground tunnels and chambers for staging events and housing animals. The Colosseum is an iconic symbol of Roman architecture and engineering, with its elliptical shape and tiered seating arrangement. The amphitheater's construction required over 100,000 cubic meters of travertine stone and concrete, showcasing the scale of Roman building projects. The Colosseum remains one of the most visited tourist attractions in Rome, with millions of visitors exploring its corridors and galleries each year. These case studies of specific engineering projects highlight the ingenuity, scale, and lasting impact of Roman engineering on the built environment. The Pont du Gard aqueduct and the Colosseum stand as testaments to the advanced technological capabilities and architectural achievements of the ancient Romans. The legacy of Roman engineering is a testament to the ingenuity and advanced technological capabilities of the ancient Romans. The Romans were pioneers in the use of concrete as a building material, allowing them to construct massive structures such as the Pantheon with its iconic dome. The dome of the Pantheon, with a diameter of 143 feet, remains a marvel of engineering and architectural design. Roman aqueducts, such as the Aqua Claudia, delivered an impressive 190,000 cubic meters of water per day to the city of Rome, showcasing the Romans' expertise in hydraulic engineering. The Roman road network, spanning over 250,000 miles, facilitated trade, communication, and military movements across the vast expanse of the empire. The Pont du Gard aqueduct in France, with its 3 tiers of arches spanning the Gardon River, stands as a UNESCO World Heritage Site and attracts over 1 million visitors annually. The Colosseum in Rome, built in 70 AD, could accommodate up to 80,000 spectators and remains one of the most visited tourist attractions in Rome. The Romans' commitment to urban planning and architecture is evident in the grid-like street patterns, public spaces, and monumental structures of Roman cities. The Romans' systematic approach to managing conquered territories through the establishment of colonies, granting of citizenship, and appointment of governors ensured the stability and prosperity of the empire. The enduring impact of Roman engineering can be seen in the lasting legacy of their structures, such as the Pont du Gard Aqueduct and the Colosseum, which continue to inspire awe and admiration. The Romans' technological achievements have left an indelible mark on the world, shaping modern architecture, infrastructure, and engineering practices.